Hello my viewers, welcome once again to my channel, Israeli Math Concept. In this tutorial, I'm going to show you how to solve a given quadratic equation using completing the square method. Do well to subscribe to my YouTube channel for subsequent video as regarding to this given topic. Alright, remember that the general form of quadratic equation is ax squared plus bx plus c equal to 0, where the a, the b, and the c respectively are called the numerals or constant, and the highest degree of the known variable x is 2, and this quadratic equation is equated to 0. Now, the first thing we are going to do whenever we are asked to solve a given quadratic equation using completing the square method is to make this s squared to become unity. What do I mean by that? We want to make the coefficient of x squared to be 1. So once we succeed in making the coefficient of x squared to be 1, automatically we've made it to become unity. So what do we do to make the coefficient of s squared to become 1? The first thing we are going to do is to take this positive c to the right side of the equation to become negative c. Hence we have ax squared plus bx is equal to the positive c coming to the right side of the equation. It will now become negative c. Then the next thing we are going to do is to divide through of this given equation by the coefficient of x squared, and the coefficient of x squared is a. So all through of this equation we divide it by a, which is the coefficient of x squared. Hence we have ax squared all over a plus bx all over a is equal to negative c all over a, such that a will cancel out a and we are left with x squared, then plus bx all over a is equal to negative c all over a. Remember, we've succeeded in making x squared to become unity, and I said prior that to make x squared to become unity means making the coefficient of x squared to become 1, and obviously the coefficient of x squared here is 1. Then what is another step we have to take? We now want to halve the coefficient of x, and the coefficient of x here is b over a. So halving it means looking for the half of b over a, which is the coefficient of x, such that we have half of b over a, and half of b over a is something as saying b all over 2 times a is 2a. Then we now square what we get from the half of b over a, which is the coefficient of x. We now square the product of it such that we have b over 2a all squared. And when we square it out, b squared is b raised to the power of 2, and 2a squared means 2 times 2 4, and a times a, which is a squared. So this is what we were able to get as the product of squaring this b over 2a. Alright, the next step we are going to do is that we are going to add this b raised to the power of 2 all over 4a squared to both the left side of this given equation and the right side of this given equation. Let me call it equation, maybe equation 1. So we want to add b squared all over 4a squared to both the left side and the right hand side of this given equation 1. Hence we have s squared plus b over a x plus, remember, we want to add this b squared all over 4a squared. But because b squared over 4a squared is the same thing as saying b over 2a squared, so let me take b over 2a squared and now include it to this side, making it b over 2a squared. And this is equal to negative c over a plus, we are still adding this b over 2a as I added here. But let me choose b squared all over 4a squared. Remember that this b squared over 4a squared is the same thing as saying b over 2a squared, because this was what we squared out to get this. So whether I add this or this to both sides of the equation, they are the same thing. But the reason why I choose to add b over 2a all raised to the power of 2 to this side is because I observe that my x has the power of 2. So I also want to make it applicable to b over 2a having the same power of 2, such that I can combine their powers together. Then I have x plus b over 2a, b over 2a all squared. So I try to put b over 2a to this side of the equation so that I can add their powers together. Remember, I didn't use this bx over a again because this bx over a, remember, was what that gave birth to this b squared over 4a squared. Hence, I had to eliminate it, taking only s squared and b over 2a raised to the power of 2. But because they have the same square, I had to put their square together in the same bracket. And that is equal to, when I take the LCM of a and 4a squared, I'm going to have 4a squared. Such that a divided 4a squared, I'm going to have 4a. And 4a multiply negative c, I'm going to have negative 4ac. Then plus 4a squared divide 4a squared, it is 1. And 1 multiplied b squared is still b squared. Then I take the square root of both sides of this given equation. And taking the square root of both sides of this given equation, I'm going to have all square root of x plus b over 2a all squared is equal to plus or minus. The reason for this plus or minus is because the roots of quadratic equation should be up to 2. And what is the roots of quadratic equation? They are the answers you get after solving your quadratic equation. So putting plus or minus indicates that the roots of quadratic equation should be up to 2. Hence, this is equal to plus or minus square root of negative 4ac plus b squared all over 4a squared. Alright, then remember the square, we cancel out the square root. Then we are left with x plus b over 2a. We are left with x plus b all over 2a. And that is equal to plus or minus, remember, all square root of negative 4ac plus 2a can be splitted in this form, negative 4ac plus b squared all over square root of 4a squared. The reason is because one of the rules of surd states that whenever you have all square root of a over b, it is something as saying square root of a all over square root of b. The same thing is applicable here. All square root of negative 4ac plus b squared all over 4a squared is something as saying the separate sort of negative 4ac plus b squared all over the separate sort of 4a squared. Such that we have that x plus b all over 2a is equal to plus or minus. We cannot find the square root of this given numerator because it will be difficult for us. Hence, let's allow it to retain its position as negative 4ac plus b squared. But it is more convenient for us to find the square root of the denominator because the square root of 4 is 2 and the square root of a squared is a. Hence, we have x is equal to b over 2a. Coming to the other side of the equation will be negative b all over 2a plus or minus square root of negative 4ac plus b squared all over 2a. Very simple. Then the next thing we are going to do is to look for the LCM of 2a and 2a. And their LCM is still 2a. Then 2a divided by 2a, we have 1. And 1 multiplying negative b is still negative b. Then plus or minus, then 2a divide 2a is 1. And 1 multiply the square root of negative 4ac plus b squared will still be negative 4ac plus b squared. This is something as saying x is equal to negative b plus or minus all square root of. I can still rearrange this because addition is commutative, hence I can have b squared minus 4ac all over 2a. This is our answer. Remember, whenever you are asked to solve a given quadratic equation using completing the square method, the exact routine we followed in solving this given question is the same routine you are going to follow in solving your quadratic equation using completing the square method till you get your final answer. And remember that this plus or minus indicate that we should have up to two rules of the given quadratic equation. Thank you for viewing. Thank you for watching. Remember to follow me on Facebook and at the same time to subscribe to my YouTube channel. It's really math concept so that whenever I upload a new video, you'll be notified. Remember to share this video. Goodbye. See you next time.